In this video, let's see the concept of charge distribution in the form of line charge, sheet charge, and volume charge distribution. Introduction. Electric charges can be distributed in different ways. Understanding the concept of line charge, sheet charge, and volume charge is a crucial in studying electromagnetism. Line charge, sheet charge, and volume charge are three different ways of distributing electric charge in space. So let's consider an electric charge where the charges are the same, repulse each other. If the charges are different, they attract each other. For let's consider when positive and positive charge is kept, two positive charges repel each other being a same charge. When negative and negative charged are placed in the same row or a line, the negative charge repel each other. So for example, let's consider a positive and a negative charge placed in a line. So they get attracted. So being opposite signed, so magnetism property attracts when it is in opposite sign. Let's see about line charge. What is line charge? So line charge refers to a distribution of electric charge along a one-dimensional line. It can be represented by a line of charges with each charge contributing to overall line charge. Examples of line charges include an infinity long wire with a uniform charge distribution or a charged rod. The charge distribution can be defined in the form. What is volume charge? Volume charge refers to the distribution of electric charge with a three-dimensional region. It can be represented by a charged volume where the charge is distributed throughout the entire volume. For example, volume charge includes a charged sphere or a charged cube. Now let's see the characteristics of line charge. Line charge is a linear charge density, which is the amount of charge per unit length along the time. The electric field produced by a line charge is radial and decreases with time from the line charge. The electric potential due to a line charge varies logarithmically with distance from the charge. So from the Gaussian's law, let's consider an electric field due to a positive line charge where E is equals to 2 pi r h is equals to rho by h by epsilon naught. So the electric field is equals to rho by 2 pi epsilon naught r. Similarly, electric field due to negative line charge is E is equals to rho by 2 pi epsilon naught. So the net electric field of both the line charges AR is equals to AE positive plus AE negative, where rho 2 pi epsilon naught plus R and 2 pi rho 2 pi epsilon naught E is equals to R is equal to, as both fields are in same direction. It is rho is equals to pi epsilon naught R. Sheet charge characteristics. Sheet charge as a surface charge density, which is the amount of charge per unit area as a surface, where the electric field produced by a sheet charge is perpendicular to the surface and constant at a given distance. The electric potential due to a sheet charge is constant at a given distance from the surface. So surface density is equals to dq by dA. Sheet charge characteristics. sheet charge as a surface charge density, which is the amount of charge per unit area as a surface, where the electric field produced by a sheet charge is perpendicular to the surface and constant at a given distance. The electric potential due to a sheet charge is constant at a given distance from the surface. So surface density is equals to dq by dA. Now let's see about volume charge characteristics. Volume charge as a volume charge density, which is the amount of charge per unit volume region. The electric field produced by a volume charge depends on the charge distribution within the volume. The electric potential due to a volume charge depends on the charge distribution within the volume. Now we will put this above the equation. The electric field due to continuous charge distribution, we get the phi for the volume charge density. E is equals to 1 by 4 pi epsilon naught rho by rho dV by r square, where unit charge positive pointing towards the P, the element delta V. So conclusion, the line charge, sheet charge and volume charge are different ways of distributing electric charge. Understanding their characteristics and calculations is important in analyzing and solving electrical problems. The concepts are fundamental in study of electromagnetism and have various applications in physics and engineering. Thank you.